Hello friends, welcome to our student support program for grade 11. At the end of a lesson, you will use notation f dash of x, dy by dx, and apply differentiation to gradients. So let's begin. Before we start with today's lesson, let's have a quick recap on some rules of differentiation. If y is equal to ax to the power of n, dy by dx is equal to an x to the power of n minus 1. If y is equal to ax, dy by dx is equal to a. If y is equal to a, dy by dx is equal to 0. If y is equal to f of x to the power of n, then dy by dx is equal to n multiplied by f of x to the power of n minus 1 multiplied by the differentiation of the function within the brackets, which is f dash of x. The product rule. If y is equal to uv, where u and v are functions in x, then dy by dx is equal to u multiplied by dv by dx plus v multiplied by du by dx. The quotient rule. If y is equal to u over v, where u and v are functions in x, then dy by dx is equal to v multiplied by du by dx minus u multiplied by dv by dx over v square. Now let's apply these rules of differentiation to calculate gradient at a given point. If y is equal to f of x, then dy by dx equal to f dash of x is the gradient function. The value of f dash of x is the gradient at a given point. That is, to calculate the gradient at a given point, we need to substitute the value of x at that point in the gradient function. Let's apply this to some examples. Example 1. Find the gradient of the curve y is equal to x squared plus 5x minus 11 at x is equal to 2. First, we are going to calculate dy by dx. dy by dx is equal to 2x plus 5, which is the gradient function. Now, to calculate the gradient at x is equal to 2, we substitute the value of x by 2 in dy by dx to get the gradient, which is equal to 2 multiplied by 2 plus 5, which is equal to 9. That is, the gradient at x is equal to 2 is 9. Example 2. Calculate the gradient of the tangent to the curve y is equal to x minus 1 to the power of 4 at x is equal to minus 2. Now let's not forget that by definition, the gradient of the curve at a given point is also the gradient of the tangent at that point. dy by dx is equal to 4 multiplied by x minus 1 to the power of 3 multiplied by the differentiation of the function within the brackets, which is 1. Simplifying this, we get dy by dx is equal to 4 into x minus 1 to the power of 3. Now, at x is equal to minus 2, gradient of a tangent is equal to 4 into minus 2 minus 1 to the power of 3. Evaluating this, we get minus 108. Example 3. If y is equal to x cubed plus 5 over 2 x squared plus 2x minus 3, for what range of values of x is dy by dx less or equal to 0? dy by dx is equal to 3x squared plus 5x plus 2. Now we need to calculate the range of values of x that satisfies the inequality dy by dx less or equal to 0. First, we substitute the left-hand side. 3x squared plus 5x plus 2 is less or equal to 0. Here we need to recall solving of quadratic inequality. First, we factorize the left-hand side. 3x plus 2 into x plus 1 is less or equal to 0. Then, we look for the values for which the inequality is 0, which we call critical values. Here, the critical values are minus 1, minus 2 over 3. It is good practice to write the critical values in ascending order. The critical values divide the quadratic in 3 ranges as follows. X is less or equal to minus 1. Minus 1 is less or equal to x is less or equal to minus 2 over 3. X is greater or equal to minus 2 over 3. Now let's check the sign of dy by dx for the first range, that is, x is less or equal to minus 1. In order to do that, we take any value of x that satisfies this inequality. For example, let's take minus 2. Substitute minus 2 in dy by dx. We get 3 into minus 2 square plus 5 into minus 2 plus 2, which is equal to plus 4. Therefore, for the range x is less or equal to minus 1, dy by dx is positive. Let's check for the second range. We take any value of x. For example, negative 0.8. We substitute it in dy by dx to get 3 into minus 0.8 to the square plus 5 into minus 0.8 plus 2, which is equal to minus 0.08. That is, dy by dx in this range is negative. For the last range now, we take any value of x. For example, we can take 0. Substitute it in dy by dx. 3 into 0 to the power of 2 plus 5 into 0 plus 2, which is equal to plus 2. dy by dx in this range is positive. Now, out of these 3 ranges, which one will satisfy our inequality dy by dx less or equal to 0? That is, dy by dx negative. It is that part of a curve which lies below the x-axis. From the table, we can observe that the middle range satisfies this inequality. Therefore, range of values of x for which dy by dx is less or equal to 0 is minus 1 is less or equal to x is less or equal to minus 2 over 3. Example 4. The gradient of the curve y is equal to ax squared plus bx plus 1 at the point 1, 8 is 1. Find the values of a and b. At 1, 8, first we are going to substitute these values in the curve to get a into 1 to the power of 2 plus b into 1 plus 1 is equal to 8. Simplifying this, we get a plus b is equal to 7, and we label this as equation 1. Next, y is equal to ax squared plus bx plus 1. We calculate dy by dx to get 2ax plus b. Given that gradient is equal to 1 at x is equal to 1, we substitute these values in dy by dx to get 2a into 1 plus b is equal to 1. Simplifying this, we get 2a plus b is equal to 1. We label this as the second equation. We rewrite the two equations. A plus b is equal to 7. 2a plus b is equal to 1. Now we solve these two equations simultaneously. Subtract equation 2 from equation 1 to get minus a is equal to 6, which is equal to a equal to minus 6. Replace a is equal to minus 6 in equation 1. Minus 6 plus b is equal to 7. b is equal to 7 plus 6, which is equal to 13. Therefore, a is equal to minus 6 and b is equal to 13. Now that we have done a few examples, you can do these exercises on your own. Number 1. Find the gradient on the following curves at the given points. Number 2. The gradient on the curve y is equal to ax squared plus 7x plus 9, where x is equal to minus 1 is 11. Find the value of a. Number 3. Find the coordinates of the points on the curve y is equal to 4x cubed plus 15x squared minus 18x plus 6, where the gradient is 0. Number 4. If the gradient on the curve y is equal to ax plus b over x at the point 1, 5 is minus 1, find the values of a and b. Number 5. The equation of the curve is y equal to 2x squared over 3x plus 5. Find the values of x for which dy by dx is equal to 0. Here are some links that you can visit to help you with this lesson. Friends, today you have learned how to use notations f dash of x dy by dx and apply differentiation to gradients. We have come to the end of this program. I hope you have enjoyed it. Till next time, it's goodbye.